Subscribe to this YouTube channel by clicking the subscription button below. For future webinars and online short courses, please visit our website at australianwaterschool.com.au. Welcome to this Australian Water School webinar brought to you by IceWarm. It's our 66th webinar. We're so glad to have you. Today we're going to discuss connecting flow and ecology in the Koshi Basin of Nepal, and it will be presented by Dr. Tanya Doody from CSIRO. It's great to be here with you. My name's Trevor Pillar. I'm the National Partnerships Manager here at IceWarm and the webinar chair. This webinar series seeks to bring you the thought leaders working in the global water sector. Yes, so it's great to have you. Look at the map there. You'll see spread right across the Americas, Africa, Asia, and Europe, and of course Australia and New Zealand. Many. Thank you for joining us. We're so pleased you could do that. You can see from the screen there's a whole lot of free webinars coming up. I won't go through each one, but cover a vast range of modelling, ecosystems, resource management, water solutions, and then a whole lot of courses, of course, online courses below that. Join our webpage or Twitter page and you'll see the Twitter feed and you'll see the details of those courses. We'd love to have you join us. Dr. Tanya Doody is a research scientist specialising in plant physiology and water relations in floodplain and forest environments. She joined CSIRO in 1993 and has undertaken research focusing on groundwater-dependent ecosystems. That's her forte. Nice to have you, Tanya, from Adelaide in South Australia.
Thank you very much, Trevor. It's lovely to be here.
We're looking forward to hearing what you have to say with your background there. I see at the bottom there, water balance projects within the Murray-Darling Basin. You have a wide reach in your research, and today is going to be a great feast of what things that you cover. Well, that's enough from me. I'll hand right over to you, Tanya.
Thanks very much, Trevor, for that lovely introduction. So as Trevor briefly alluded to, today I'm going to give a bit of a presentation about probably one of my favourite projects I've undertaken in my 25 years at CSIRO, and it's been about linking river flow and ecology in the Koshi Basin in Nepal. So before I start, what I'd really like to do is provide a huge acknowledgement and a very big thank you to Susan Cuddy, who's probably not online, but she's certainly been a huge part of the talk and the results that I'm about to present today. So the project that I'll present after this couple of slides has been a project that falls within the Sustainable Development Investment Portfolio, or we call it the SDIP. And this is an Australian government initiative funded by DFAT in Australia. The aim or the goal of the portfolio is to increase water, food and energy security in South Asia, but it also aims to improve integrated river basin management. In about mid-2015, I was offered the opportunity to be able to try and make a difference to rivers, the environment and people in Nepal by undertaking a small component of research within the Koshi Basin project, which was about identifying the level of understanding of the links or the relationships between river flow changes and ecology in the Koshi Basin. And when I mention ecology, what I'm talking about is the birds, the fish, buffalo, vegetation, to name a few. And so when I'm also talking about understanding this link between river flow and ecology, what I'm saying is that, you know, a good example is a fish. Not only does a fish rely on water, it actually relies on certain aspects or characteristics of water to make sure it can exist through its life period. And so a good example is fish might need river water, which is a temperature of 20 to 22 degrees Celsius. And if these conditions are not met, then reproduction is unlikely to happen because that's the temperature range they need to spawn. So the flow ecology link here is that the fish rely on a specific river water temperature to reproduce and flourish. There are many flow ecology relationships, and a lot of us have been investing in these in river basins across the world, such as the Murray-Darling Basin in Australia and the Colorado River Basin in America. But we didn't have a very good understanding of what was happening, I guess, in Nepal, the greater Nepal, but also the Koshi Basin. So another big aspect of this project in general, but also something that I will link to in my PowerPoint, is The SDIP portfolio really has a focus on the most vulnerable, including poor women and children. And so within this project, the Ecology Flora project, we tried really hard to make sure we're thinking about livelihoods and we're thinking about gender and how those aspects are affected by changes to flow regimes. So just as a bit of background, Nepal is a developing country. It requires an reliable income source in order to advance and to be independent of other countries. But income producing activities provide threats to the environment. And so we face this currently in Australia, Europe, America. So it's no different in Nepal. So this slide is outlining some of those threats, and they come from agriculture, which requires pumped irrigation or flood irrigation, and hydropower, but also just humans in general. And this picture is depicting some of the resources that have been extracted from a river. And so therein lies problems with over-extraction as well. So if we think about hydropower and its development, it's seen as a key way to progress the country, given that there are these plentiful water supplies provided by the Himalayas. And also to provide power to rural populations where 40% of the country currently have no power. So Nepal, in general, they prefer a run-of-the-river hydropower system, and there's an image there that will show what that consists of. And so this is a system which creates a dam at the top of the river, and also a diversion channel. And this diversion channel can divert water out of the river and through these tunnels for up to 15 kilometres of the length of the river. And so this significantly alters the flow regime that would normally occur in that stream. And this then leads to these problems that might be happening, such as the fish and the links between flow and ecology. The dam itself up the top is also a problem, as it's disrupting the longitudinal river connectivity. So it makes it hard for fish to go upstream and downstream easily now that there'll be a dam. So the overall vision in Nepal, from my understanding, is that there is a desire to create a cascade of hydropower for different river systems. So this means there could be 5 or 6 different hydropower dams and diversions along one river stretch in Nepal. So this then creates dammed river systems, similar to the Murray-Darling Basin and the Southern Murray system with the locks and weirs. And this will have significant effects on plants and animals, which are reliant on the natural river flows to maintain their health and biodiversity. So I think we all know Nepal's home to the Himalayas, so some of the highest, I guess, mountain range in the world. But it's actually this Himalayan elevation, and then you move into some mid-hills and you move into the flat Terai. And it's this elevation gradient which provides the pivotal water resources and the significant variation in habitats that brings for biodiversity in Nepal as a whole, but also in the Koshi Basin. And water is critical to sustain the environment. So in the Koshi Basin, and that's highlighted in orange in one of those images there, rivers within the basin drain a catchment area of over 87,000 kilometres squared, 40% of which lies in Nepal, because some of the Koshi Basin lies in Bhutan and some in India. China, probably, not Bhutan. So today what I'll talk about is the stage 1 of the project of linking flow and ecology, and towards the end I'll briefly provide an overview of where we're up to in a stage 2 component. So why did we want to do this project? It was to try and improve the understanding of important water and habitat requirements of water-dependent ecological assets. So these are the ganga dolphin, the vegetation, the birds that I've previously mentioned, and their relationship with river flow regimes, which strongly influence the aquatic biodiversity. Now, these ecological assets that I've mentioned, within them we have specific indicator species. So in Australia and probably the US, we've done a lot of research to try and identify what are our indicator species. So that might be a specific bird or several fish species. And what these indicator species do is they show a change when river flow changes. It could be reduction in reproduction, or they could die, such as the fish kills that have happened in the Murray-Darling Basin, or they could just move somewhere else because the conditions aren't significant, well, aren't similar to what they require. So we look at these to tell us through changing an observation if the river has changed in some way, the flow has changed, or the wetland inundation has altered. So these can either be flora and fauna. They're generally easy to observe, measure, and alter behaviours when flow conditions change or are not suitable. So why do we want to do this study? Why do we care at all, I guess, is probably an overarching question. And it's to provide a lasting legacy to aid maintenance and, where necessary, improvement of the health of aquatic ecosystems under increasing hydrological pressure. So specifically today I'm talking about Nepal, but this is relevant to other river basins across the world as well. And so we also want to identify some of the impacts to livelihoods of these river flow changes and potential implications for women and children who rely on the river as a source of food and income. So water requirements, what I'm talking about here is the way the flora and the fauna depend on river water. So just clarifying a few terms before I kick off into the greater presentation. So to start stage one, I went to Nepal along with Sue, and what we did was we managed to engage some of the, I guess, most prominent in-country ecologists who are undertaking research studying fish, birds, the ganga dolphin, flora, buffalo, crocodiles, macroinvertebrates, but also there were some experts in gender and biodiversity. So at the end of a 2-day workshop, we were trying to pull out from these experts what their understanding was between the link between their ecological expertise. So if it was birds, what's the link between birds and river flow? And at the end of 2 days, what became quite obvious was it's actually not something that's thought about too much. So there are a few studies, and I'll talk about them in a minute, but predominantly what they do in Nepal and probably other countries as well is a lot of time is spent understanding where species are and how many species there are. So this was starting to provide for them a new way to start thinking about things. So at the end of that 2 days, I came back to Australia, and I guess my option then was to think about how I was going to progress this further. My intention with this workshop was to start pulling out some of those known links. But by the time I got home, I didn't have any links. So the next step was to undertake a series of literature reviews. So these were intended to identify any known water requirements of riverine flora and fauna across Nepal. So I wasn't restricting that review to the Koshi Basin. I was just looking to see what was known countrywide. Again, there was a sparse amount of data, and from that, I was able to then start developing some quite basic conceptual models to try and understand and provide a pictorial of some of those links of flow and ecology that have been identified within the literature. Some of these relationships were noted from observation, so they were qualitative observations, but some of the information I pulled out of the journal papers were quantified by field studies. So ultimately from there, I had these conceptual models. So we went back to Nepal, we had another workshop after providing those conceptual models to the key ecologists. So we didn't have conceptual models for everything because data just wasn't available. So then we had this discussion about, okay, what's stored in your head? How can you add to these conceptual models, and particularly in that qualitative observational way? So we started to then unpick and develop some more information to understand these links between flow and ecology. It was also decided that what we'd really like to do is actually make these links known more widely outside of journal papers, which are not easily able to be found, I guess, by a lot of people. So what we decided to do was each ecologist would have a chapter, they would have a conceptual model. If one was available, they could create their own. And so we brought all those chapters together to provide a publication. The link is shown on this screen. The upshot, I guess, from that publication is it's freely available on the internet, but again, it shows that there is limited information available that's linking flow and ecology. And so with that limited flow knowledge, how do we then start translating what future river flows might be and how they impact ecology? So I'll talk about that a little bit later, but for now, I'm just going to present some of the flow ecology relationships that we were able to define through this process. So the wild water buffalo or ana, it's on the brink of extinction in Southeast Asia. Again, there's very little known about this animal around its key habitat and its key water requirements. So some of the information that I was able to pull out of the literature identified that buffalo require water bodies to wallow. So they need to do this through, especially the hot periods of time through summer. For 6 to 8 hours a day, they need to almost be completely submerged in order to reduce heat stress. So this was a quantitative relationship. Some studies have been done to try and understand how long the buffalo needed to be submerged. And so if they weren't able to wallow and keep cool, the buffalo moved somewhere else where they'll fit into the wallow and find a habitat that is suitable for them. Otherwise, they will die or migrate to other areas with suitable habitat. Another piece of information we were able to determine was that buffalo require tall grassland composed of what is essentially a sugarcane species for grazing. And so that grassland had to consist of 80% of that sugarcane. So you start to understand here that we know water buffalo need water to wallow or they'll get hot, and one of their main food sources is this sugarcane species. I won't show all the conceptual models because they get a bit confusing, but I just wanted to provide one example of the kind of information we could pull out of the journal papers or reports and what they might mean to future river management. So in this example, it's on the left-hand side, we're showing some of the relationships in the journal papers that relate to natural wetland environments. And on the right with the blue are some of the threats that might occur if you changed the flow regime to impact those natural environments. So ultimately you'll lead to habitat degradation, which might be reduced grassland, lack of water holes, or reduced forests. Some of the knowledge gaps that quite easily stood out once we constructed these conceptual models was that we actually have no idea what size of pond does a buffalo need. Obviously, they're a big animal. Do they need to be snug in the pond? Do they need the pond to be a bit bigger so the water stays cooler? They don't want to heat up the water. What depth do they need the pond to be? What temperature and what sort of water quality? So these knowledge gaps are all now things that we've collated and that Nepalese scientists can start thinking about as they start conducting future research in their field of expertise. So the Ganges River dolphin or the Ganga dolphin is very, very highly threatened in Nepal. There's a few rivers that have the dolphin freely swimming, but many of them are caught the other side of the Koshi barrage down at the Koshi Tapu Wildlife Reserve, and they can't get back into the Koshi River from the Nepal side. There's probably been a lot more research around the Ganga River dolphin. It's, I guess you would call it, quite a engaging species. People like dolphins, they want to know what they can do to protect it. So some of the things we were able to define was that they need a water depth of about 5 meters in order to swim and be happily swimming around in the water. And that gill nets related to fishing by humans, gill nets that went down to a depth of 4.5 meters become a threat to the dolphin as they can't get under the nets and they'll either get tangled in the nets or go somewhere else, but more likely they'll get tangled. The dolphin also require channel widths that are a specific size to ensure that there are foraging opportunities, opportunities to seek food. So some of the knowledge gaps that came out from these literature reviews was we actually really don't have an understanding of the water quality that might be required, the water temperature, flow velocity, and where the dolphins might go in dry seasons. Crocodiles, there are two species in the pool. We have the mugger and the gharial. They're highly threatened again. So we know that crocodiles require shade by 2 p.m. in winter to manage thermoregulation, otherwise they'll get too hot. They have specific water depth requirements that are related to having babies and the depths that babies can swim in without drowning in, and adults require water depths greater than 4 metres. And the mugger crocodile require basking substrate close to deep water with good habitat for camouflage. So they require good riparian vegetation, suitable water depth and riverbanks for burrowing and to provide that protection. Knowledge gaps include water requirements for breeding and food requirements. Now, the gharial species no longer occurs in one of our Ramsar wetlands in Nepal, so there's also a big knowledge gap around how do we start, what information do we need to start reintroducing that species to that environment. Birds, there have been many studies counting birds. Where are they? How many of them? But very few are linked to that river flow component that I'm so interested in. Many species access water-dependent food sources such as fish, snails, insects, and species nest along river banks or in water-dependent grassland. One species, the swamp francolin, requires a high-density grass 2 to 3 metres tall in order to hide, reproduce, and I guess just to be camouflaged and forage. Some of the knowledge gaps for birds are we don't understand water requirements for river birds because we can have river birds, we can have wetland birds, we can have birds that are more terrestrial. And we have very little idea about the breeding requirements and the depth to water in the reed beds. Fish, there's over 140 species, and that's probably quite an underestimate. And again, there are a couple of these flow ecology relationships we could untangle, such as the snow trout, which needs to spawn upstream, so it must migrate. Specifically in March to June, it needs water temperatures of 14 to 21 degrees, it needs clear water and a water depth of 30 to 60 centimetres to lay eggs in gravel along stream banks. Now that is a perfect example of the intricacy that we're trying to pull out of some of these flow ecology relationships. Not just one aspect of it, but this has several aspects. And then we have the carp, which requires a water temperature between 25 to 10 degrees for reproduction. Knowledge gaps include water quality, temperature requirements for other species, and breeding requirements. So in terms of the livelihoods, rivers and wetlands support livelihoods of millions of people. And this woman here, she's holding it's a fern. It's taken from the riverine system and it's edible. So apparently the day I took this photo, I'd actually eaten this the night before, but I had no idea. It seemed to be quite nice. So with livelihoods, important ecosystem functions such as nutrient cycling, primary productivity lead to benefits such as clean water, food provision, recreation and spiritual values for these local people. And river diversions can impact cultural events, but also include reduce fish stock. So I heard one story where hydropower has been installed, rivers diverted, and a cultural event attracting 3 million people now has no or very little water available in the hottest period of the year. Some of the knowledge gaps, how women and children rely on water and wetlands, and also the percent of income from aquatic areas. So how does this all fit into the future water management in Nepal? So the current water planning that's going on encourages integrated water resource management to ensure sustainable water use to meet the needs of the current generation, but without compromising the needs of future generations, while at the same time maintaining the freshwater ecosystem of Nepal. There's future science challenges here where I've shown some of these basic flow ecology relationships. So more field studies can be undertaken and community consultation established to further these flow ecology links. Start bringing the local people in to undertake the monitoring because they seem really keen to do so. So we have a challenge for the scientists in Nepal to build on the work undertaken here by undertaking further field studies and community consultation. And we emphasise that the water resources need to be monitored, especially where increasing abstraction is predicted or flow disruption from hydropower development operation in order to ensure detrimental ecosystem decline doesn't occur or keep occurring into the future. So this is the stage 2 component, which I'll briefly talk about. So at the end of our report, we came up with a few ecology flow relationships, and there was a little package of money. And so I really was keen to actually attract some Nepali students and take them out to the field and teach them how to start measuring these flow ecology relationships. So we put together a package of 3 scholarships for 3 master's students. We were also keen to ensure that, hopefully we'd have some females would apply for these scholarships. And at the end of the day, our best candidates were 2 females and 1 male. So they're out in the field and they're measuring the links between birds, aquatic vegetation, and macroinvertebrates. But I was also really keen for them to undertake this as an integrated study. So instead of going out at different times, they had to go out at the same time and they all had to learn off of each other. So at this point, they've now finished 4 seasonal field trips over 12 months, which was the field requirement. So they've been in summer, autumn, spring, and winter. I went with them a few weeks ago on their final field trip, and I was really impressed that, the male Aditya is doing the birds, but the 2 females, Sunita and Tika, could both also identify some of the bird species. They could all identify the macrophytes and some of the macroinvertebrates as well. So what we wanted to do was link the presence and absence and species diversity to river flow and wetland extent. It was also really important to us in terms of capacity building. And so after my most recent trip, it seems apparent now that we have 3 supervisors, actually there's 4 supervisors, and they're now thinking more in terms of their research about how they can start thinking about other aspects of the environment as well as their ecological asset when they're undertaking research. And on top of that, we've got these 3 students who have now trained in how to measure flow ecology relationships. So watch this space, because I'm hoping maybe this time next year I'll be back here and I'll be able to report the outcomes of that integrated field study. But at this point, it's looking really positive. And of course, there's always a lot of people to acknowledge when we undertake projects of this span and also across several countries. So there's a list of people there, a list of organisations and the people within them, but especially all the supervisors, all the ecologists and the authors and reviewers of our quite large report that we published in 2016. So at that point, I'm happy to take some questions.
What a fantastic coverage in such a short time. There's a lot of stuff going on behind that, I'm dead certain. And you're over there often on your own time as well as a scientist. I mean, you're always a scientist, but I'm just talking to a colleague just who knows you earlier today, and was saying that he really appreciates that people who are in science like yourself also deliver personally and passionately to it. On that note, was your slide 5, was that you wading through that deep water, canoe in the background, water buffalo waiting to charge upriver, or didn't see them, but
Well, yes, it was me.
Was you? Okay, right, yeah, line up.
However, that was in the Murray-Darling Basin.
Right, okay, right. I feel much safer.
Obviously, it looked pretty good, so yeah. I could manage to.
Absolutely brilliant, Tanya. Thank you for that talk. It's absolutely great. Subhash Chand is in the US. He's a New Delhi person from principal scientist for ICAR and NIAP in the US. But he's asked this pertinent question: the deterioration of water quality. I might just ask you to open your Q&A window down there, Tanya, and you'll see the question. Deterioration of water quality, spreading pollution into the watercourses, is a continuous process since ancient times. It's due to the development of society. How can increasing pollution be stopped or minimised at a global level? I suppose it's a fairly huge question which we could take on notice, or you could make a few comments on.
Wow, where to start with that one?
Where to start, yeah.
Yeah.
We could answer a book.
I guess from the Nepal perspective, I think a lot of work still needs to be done, and I think it probably has to come from the upper levels of Parliament, whatever they are in Nepal, government, I guess. Just encouraging people to reduce pollution. So it's about improving knowledge and understanding of what produces pollution, how it's produced, but also start instigating some ways to manage and reduce pollution. So waste, like both human waste and waste of plastics, food, that sort of thing, is just scattered around the landscape. So there's some more fundamental basics to gather those waste to a common point and start managing what should be done with them after that.
Yep.
Huge problem.
No, huge problem, absolutely right. Lakshmi is in Nepal, and he's asked, Koshi is a huge basin. Have you considered a specific sub-basin to do this study, or taken a whole basin as for modelling? What is the current situation of the basin in terms of risk and sustainability of ecology with current flow? So there's two basic questions. You might be able to see that on that Q&A.
Thanks, Lakshmi. It's a good question. Yes, Koshi Basin is huge. From that first workshop, it became pretty apparent that we couldn't just focus that report to the Koshi Basin because there was not enough research targeted to that basin. And at this point, there has been no modelling in terms of the linking of flow and ecology, but it's something we may think about as a third component after the students have finished. In terms of the current situation in risk to sustainability and current flow, I think it's going to be ever increasing as the hydropower more and more comes online upstream, and for downstream communities, it's around abstraction of that agricultural water for irrigation. So again, this is going to require some management from government, from water managers, water resource providers, to start understanding how to allocate those resources in a sustainable way that will support both the environment, humans, and also that economic requirement that we all have.
Yep. Siamsa was in Indonesia as a lecturer at University of Mataram in Indonesia. He says, what was the water requirements for flora also investigated, and was climate change impact on water availability studied?
Thanks for that question. There was very little information about flora investigated. However, to account for that, one of our students was quite passionate about researching macro phytes. So we now have 4 lots of data that's understanding the presence and relationship to flow of in-stream macrophytes at the Koshi Wildlife Reserve.
Dan Evans he's in Australia, senior associate environmental scientist with Becca, has said, interesting question here. It's in the chat line. Oh, here it is over here now. Yeah, great talk, Tanya. Wondering if flow monitoring was conducted as part of the master study student surveys, and how you got around the lack of long-term hydrological records specific to those sites being monitored.
Yeah, thanks, Dan. And that there is a fundamental requirement that needs to start being considered, I think, at the government level, is this: we need monitoring of flow. Right. So yes, at one location, we did have flow monitored over the entire 12-month period. We also were able to provide some funding for some locals to go, I think, once a week and make water depth measurements across 4 locations, and also stream width measurements. We're now trying to also grab some of that hydrological data from one of the upstream gauges, but that is quite a challenge in its own right.
Yeah. Yeah, thanks a lot, Dan. Susan's in the University of Western Sydney University, PhD student there, has asked, is the Koshi River Basin in Nepal linked to the Kosi River catchment in Kumaon, Uttarakhand?
That's a very good question, and I'm actually not sure I can answer it.
We'll
However, if you look at the presentation when it's online, there is a map there, and you might be able to pinpoint yourself, Susan, or that location and answer that question.
Yeah, that sounds good. Paul has asked, what are the strategies for maintaining wetland areas and agricultural areas in this basin?
I think the strategies are just beginning to be developed. So at the moment in Nepal, they have this 10% rule of thumb. And so what that's saying is that at any time over the year, there should always be 10% of minimum flow in any wetland or river system across Nepal in general, but also this basin. What we're trying to challenge, I guess, with this ecological component is the fact that that may not be correct and more research needs to be undertaken. And so we're trying to upskill the local citizens to start challenging that rule of thumb, that 10% rule of thumb.
Yeah, that's a good question. Thanks, Paul. SPOC University in I haven't heard of that. That's okay. Thank you for your question. Susan, again, what methods are envisaged for researching the reliance of women and children on rivers and wetlands? That's a great question.
That is a great question, and something I didn't cover in this talk because that will be in next year's talk. But basically, the universities that the students are in have provided some support for them to add on a series of questionnaires. So in their last field trip, they went out and they questioned quite a broad spectrum of people within the Koshi Wildlife Reserve. So they had jobs, they were farmers, very broad spectrum, to ask exactly those questions. You know, how do people, especially the women and children, rely on those water resources?
Thanks very much. Ashok has asked, he's from the Victoria University in Australia, he's asked, well, what would be the impacts of climate change on ecological sustainability, and have you studied or considered the climate change impacts?
Look, at this point, I guess you could say we're at ground zero here. So climate change is a bit of a leap forward for us. If we can get to a point where we've got enough of these flow ecology relationships to start modelling and then start doing some climate scenario models, that's something we might be able to address in the next 4 years, depending on how the SDIP program evolves. So it's not being ignored, but we just have a lot of work to do before we can even get to a point to do that modelling.
That's great. That's good. Well, look, we're really at the end of our questions now, but there's a comment made by Santosh that saying that Koshi, for you, Susan, Koshi is not related to Kosi and Kumaon. These regions are 1,000 k's apart. Thanks a lot, Santosh. That's much appreciated. That's great. That's good to have people on board who are just back and forthing like this. Thanks everybody for being with us today. This has been it's been a fantastic time together to look at what's happening here, and we are thinking next year again. Tanya, you'll have some results from the field studies you're doing there, yes, and the integrated studies being done by students there. Yes. That would be a really great outcome. We want to thank everybody for participating today. Yes. Stay online as the feedback comes through, and the recording will be mailed to you, and you can see there a ton more webinars coming up. So it's been a great time, and look, most of all, thanks a lot, Tanya, for your time and effort in getting us together. It doesn't take a short time to do this in the middle of your day at CSIRO, but we do appreciate the effort in doing this, and it's been terrific to hear about the stuff going on far afield as Nepal. But once again, any final comments from yourself?
No, not at this stage. Other than thank you everyone for your time.
It's been great. Thanks everybody. See you again next time. Bye for now.
Thank you. Bye.
Subscribe to this YouTube channel by clicking the subscription button. For future webinars and online short courses, please visit our website at australianwaterschool.com.au.